Copper can be produced from a rock that contains CuFeS2. Balance the equation for the two stages in this process. Now these equations do look quite complicated. It may be that the time spent on this might not be time well spent for you in an exam. If you think that you're going to struggle, it might be something worth coming back to. But we're going to have a go at it. I'm going to give you some tips of where to look for. So the first thing I would look for is things that appear only in one compound on each side, like this Fe and this Si. Because once we figure out their amounts, we will be able to balance those things fairly quickly. The other thing I'm going to notice is there's a lot of copper on the right-hand side already. So what I'm going to try is I'm going to keep these as a 1. I may have to come back and change this later. But if that is a 1, then in total there were 4 coppers, and copper only appears in this very first compound on the left. So if I start from that, I now know that there are 4 Fe's, so I'm going to go over here and put 4. So I've done the Fe. Now because I've done the Fe, I've got 4 Si's, so I'm going to go over here and put 4. And now because I put the 4 in front of this sulfur containing compound, this is the only place that sulfur is, we've got 8 S's on the left. Now we've already got 1 S here, so we would need 7 more on this line, and that's the sulfurs taken account of. So if we have a look, we've done the coppers, the irons, the sulfurs, the silicons. We just need to do the oxygens. We've got numbers in front of everything on the right. So I've got 1 oxygen here, 14 oxygens here, and 12 oxygens here. So if I add those up, that's 27. And on this side, I've already got 8 in this compound. So I need another 19 here, which would make this 9.5 O2s. So by a slow process, I've managed to balance it. If I want to, I could go back and double everything so that I don't have a fraction. The second equation looks a lot simpler. Again, we can spot some things that are, the sulfurs only in one thing on each side. So let's say we do keep the sulfurs as 1. We will maybe end up with some fractions, but let's have a look. So that's the sulfurs dealt with. Now, because of that, that's the only place that oxygen is on the right-hand side. So I have 2 oxygens on the right-hand side, which means I need 2 oxygens on the left-hand side. Now what I want to do is add up the coppers on each side. So at the moment I've got 2 and 4, that makes 6. So I'm going to put a 6 here, and I have balanced the equation. So the next part of the question says, suggest 2 reasons why sulfur dioxide byproduct is removed. So the first thing we're trying to remember from our knowledge of fuels, in fuels we learned that sulfur dioxide causes acid rain. So that would be one reason to remove it. And in our group 7, we learned that sulfur dioxide is a choking gas. So it's toxic, we don't like it, it's going to cause us breathing problems. So we wouldn't want it to be in our atmosphere. So we would remove it before it was into the atmosphere. So the question continues on the next page, and we seem to have some numeracy question coming up. We've got some maths. So what we've got is we've got a passenger jet contains 4,050 kilograms of copper wiring, which is just copper. Now 4,050 kilograms would need to be converted into grams. So 4,050 and then 3 more zeros. You might want to put that in standard form. If you were to type that on your calculator and type in the times 1,000 to make it grams, your calculator will probably give it you as 4.05 times 10 to the 6 grams. Then it tells us that 1.25% of the rock is actually this copper FeS2 by mass. It says calculate the mass of the rock that we would need in tonnes. It tells us what a tonne is to make enough copper wire for a passenger jet. So let's just find out how many moles of copper wire we actually want. So that would be 4,050 times 10 to the 3, or 4.05 times 10 to the 6 if we did it that way, divided by the MR of copper, which we look on the periodic table is 63.5. So that is 63779.5 moles. Okay, so that's the moles of copper. Now, this formula CuFeS2 has 1 copper in it, so the ratio must be 1:1 with copper, because however we make that, there's 1 copper in each formula. So the number of moles of CuFeS2 equals the same. Okay, so then the next thing I would do is, well, what mass of this ore is that, of this copper iron sulfide? So mass is Mr. moles. So let's add up the MR of that, and that's coming to 183.5, and times it by the number that we have still on our calculator. And we're getting a very, very big number, 1.17 times 10 to the 7 moles, grams here. And this is equivalent to, this is the 1.25%. So if 1.17 times 10 to the 7 is 1.25%, what's 100%? You need to multiply up, don't you, times by 100 over 1.25. So we're going to do that the same down here. We want to get bigger. It's a very big number. So we're getting to 9.36 times 10 to the 8 grams, and it wants it in tons. So we're going to divide by 1,000,000, and we're going to get 936 tons. And there's a final part of the question coming up on the next page. Copper can also be produced by the reaction of carbon with copper 2 oxide. According to the equation shown, calculate the percentage atom economy for the production of copper. So remembering that atom economy is the MR of the product that you want, the NR of the useful product. So we're making 2 coppers, each at 63.5, divided by the MR of all the products. So that would be the sum of 2 coppers plus a carbon dioxide, which is 12 plus 2 16s. And then it's a percentage atom economy, so we would times by 100, and it does want the appropriate significant figures. And since the periodic table gives everything to 1 decimal place, or all these numbers that we've used have been 3 significant figures, that's what we're going to go for. So we're doing 2 times the 63.5 divided by the sum of 2 times 63.5 plus 12 plus 32. And then making that a percentage. If you do that and you give it to, the calculator says this, 74.269. So to give that to 3 significant figures, be 74.3%.